We're going to talk about choosing and designing firewalls. So our objectives for this class are to explain what firewalls can and cannot do, describe common approaches to packet filtering, which is what you'll do in your assignment with Iptables, how to establish a set of rules and restrictions for a firewall. We design a common firewall configuration and compare hardware and software firewall rules. So you need to understand that, and probably a lot of you have heard that it's important to have a firewall, but realize that firewall is only one control that you can use to stop intruders from getting into your network, or stopping bad things, bad packets from getting into your network or from leaving your network. And firewalls can be implemented in one of two ways. They can be hardware related or they can be software. If you're talking about hardware, you're talking about a dedicated device. It's going to be quite expensive, although they're usually quite user-friendly. They have a graphical user interface design for interfacing with a firewall. Software firewalls are going to be much cheaper, all the way from free, especially if you're running something on Linux, up to a few $100s for the cheaper firewalls. And the primary reason to use firewalls is to configure to block unauthorized network access, and that means coming into the network or from leaving your network. So you can do it both ways, and as we've discussed before, there are reasons that you want to keep people from sending things out of your network. One thing you need to understand is that firewalls can sit on the perimeter or the interior of your network. However, if you have a malicious insider, somebody who wants to do things on your network to your servers that's sitting on the inside perimeter, that is on your trusted network, it's difficult or impossible to stop somebody from getting into that using a firewall. There are other means of stopping people from accessing, for example, proprietary information, such as access control, which we'll go over a little later in this course. However, firewalls are not meant to do that. And of course, firewalls cannot protect connections that do not go through it. And so if you want to protect a certain network access, a certain server, you need to make sure that there's a firewall sitting in between the untrusted network and the thing that you're trying to protect. It kind of goes without saying. Okay, network firewall is a combination of multiple hardware and software components, as you'll see. One of these is called the management console. If you're talking about a hardware configuration, however, something as simple as a script, as you'll see when we talk about Iptables, is simply you sit down with a text editor and you can write your own firewall, and then you submit that to the kernel for processing, and you've got yourself a firewall. The earliest firewalls were something called packet filters, which simply means that they would filter based upon header information in the packets. And later on, you've gotten much more sophisticated types of firewalls that actually do a lot more than just looking at the headers, and we should talk about that a little bit later. Some firewalls, probably the ones that you're using on your computers at home, are designed for consumers, and they're very easy to run, such as Norton Personal Firewall Zone Alarm, which is very good. There's a free version of that. There's a Seagate Personal Firewall as well, but here's a Tiny Personal Firewall's simple interface. It indicates here, let me make this a little bigger, that, so you can take a look at it. Here we go. That firewall enabled. You can click it on or off. Obviously, if it's not on, it's not going to be doing any good. You click it on. It says it has 3 different levels here. And so the one up here, I believe, should be the most restrictive. The one at the bottom will be the least restrictive. So the more restrictive your firewall is, the less it's going to allow to go through it. But that also means the less services that people are allowed to access to. So you need to have a happy medium between security and the services you offer to your users. What do firewalls contain? Firewalls essentially contain a number of rules, and these rules specify certain things. They specify one of two things specifically. One is what traffic is allowed to come into the network or leave the network, or 2, what traffic is not allowed to come in or what is not allowed to leave. And even with some of the more powerful firewall rules, you can create customized access, for example, based upon an IP address. So for some IP addresses accessing a particular server, you may want to allow them in, and others you may block the traffic from there. Checkpoint next generation firewalls is designed to protect and monitor large-scale networks. Since we don't work with them in this class, I won't talk too much about it, but the book does a good job of explaining what Checkpoint does. You also have something called firewall appliances, which are self-contained hardware that contains all you need to do to run a firewall. So you can plug it in between the trusted network and your untrusted network and set it up with a management console, pulling something up on your screen, a graphical user interface, and set the rules graphically, which is quite nice. It's got checkboxes and buttons to push, and you can set up your firewall. However, without understanding what you're trying to protect, it doesn't really do any good to have even the most expensive firewall. So you need to understand what you want to protect first before you go ahead and start protecting it. Here's Norton Internet Security. This is actually showing, and this has actually been around for a while, is that the first time that a packet comes in, Norton Internet Security asks you what you want to do with it. So what this has done is it says threat level is a high risk. It's looked at the packet and it's saying that what this packet is trying to do looks like something that you don't want to allow through. It's a high risk for some reason. It tells you the time and date, and what the communication detected was an inbound ICMP, and they don't say what type of. Oh yeah, it does. Remote address echo reply. So this is an echo reply from something. I don't know why that would be considered. Oh yes, there's something called the Smurf attack that hopefully I'll explain a little later on as to why you wouldn't allow this in. So then it just gives you three choices. If this is permit this system to access your computer, you can hit this radio button right here, and that means from then on there's going to be a firewall rule that allows any inbound traffic from this computer, because that's what it appears that this rule will create. It doesn't mention specifically about the protocol information, just the IP address. Or you can block the system from accessing your computer. It says it's recommended, so you click on this, and that means there will be no inbound initiating traffic from this IP address right here, or you can customize access for this system. Firewalls are not a standalone solution. So if somebody says, geez, I need to secure my network, what kind of firewall should I get? You should say, well, it depends. First of all, what other types of controls are you using, such as antivirus control, access control lists for your files, what type of network intrusion detection systems are you using, what type of host-based intrusion detection systems are you using. Most people just know firewall is a buzzword, and they think that that's the end-all and be-all of security, but it's not. It's only a piece of the puzzle. And of course, firewalls do not protect from internal threats. Access control is one way of protecting from an internal threat. Remember, people who are sitting down behind the trusted network already have access to the network. And so that's why firewalls are not the solution for keeping out insider threats, but access control is one means of doing it, as well as intrusion detection systems as well. So you also need, something I need to stress, is you need a strong security policy. That is a policy that's created prior to implementing any controls that explains who should be accessing what servers, what traffic should be allowed to leave your network, and what traffic should be allowed to come into your network. And you also need employee education. Is that employees need to know what is allowed and what is not. So that means if they're allowed to install a P2P server on their computer, they need to understand that. If they're not allowed to do that, they need to understand that as well. And that'll become important for legal reasons, because if you go to fire somebody for installing something like that, but you haven't specifically prohibited that, you could be in trouble. This OPSEC, which is kind of weird, open platform for security. There's actually a OPSEC also means operational security. That's a term that's used by the military. So it's I'm not sure why they chose OPSEC. I guess because it sounds like the military term, but you can read more about that in the book. I'm not going to go over that. Okay, approaches to packet filtering. So we're talking about simple packet filtering, where the firewall is looking at the contents of the headers and it's applying the contents of the headers trying to match them to rules in your rule base to determine if there are any matches between those. And there's three different types of approaches to packet filtering. There's stateless, stateful, and packet filtering depends on position of components. That's kind of weird. I'm not sure what it means by this, but there's stateless and stateful, and we'll actually talk about that in your homework. You'll actually be creating a stateful packet filter, and we'll see why that's a lot more efficient than a stateless packet filter. Okay, a stateless packet filter decides whether to allow or block packets based on information in the protocol headers. So the protocol headers are going to be what? They're going to be any layers of the OSI model, but in particular the IP layer, which would be what? The IP address, the TCP and UDP layer, now we're talking about ports, or it could be at the application layer, so now we're talking about application layer stuff. However, in a packet filtering, only looks at the IP and TCP layer. It doesn't look at the application layer. There are other approaches that actually look at the application layer, including application proxies. So the filtering is based on common IP header features in the packet filtering, including the IP address, the ports and sockets. I'm not sure why he said socket here, because a socket is just a combination of IP address and port, and ACK bits. That's funny the way he said that. That's actually the flags that are included. So whether you're looking at a send flag, an ACK flag, a reset flag, and so on, you can include this in your stateless packet filtering. However, intruders can get around these defenses. It's not foolproof, and that's why you use it with a number of other different controls, such as access control mechanisms, as well as intrusion detection systems. The advantage for this is that it's very inexpensive. However, it's cumbersome to maintain because typically you have to a priori, that is beforehand, specify all the different rules that are going to be used in your firewall database. Okay, this is showing some simple rules. Stateless packet filtering. Notice that now we're really only filtering on three things. Actually, two things. IP address and the port number. And we can look at the source IP and the source port, or the destination IP and the destination port. And this shows you the actions that are allowed over here. And notice that there's two. There's this is funny. That's wrong right there. That shouldn't say any. That should say either allow or deny. And so you see that this is to allow something either incoming or outgoing, or to deny that. And as we'll see in Iptables, there's actually, you can break down to deny into two other categories. One of which is to drop the packet. That is just to drop it, to make it go away, not do anything with it. Or there's something called reject, which means that once a packet comes in that meets this criteria, let's see this one right here, that is, let's say anything coming in from 192.168.120.1 over any port to any destination IP, you want to deny it. If we were to reject it, that means that we'd send an ICMP packet back to the originating host here, indicating that the host is unreachable, or that it was denied access. And as I said, the other condition would be just to drop it, and that just means don't tell this host anything at all. Just drop the packet. Okay, so if we go into, let's look at the first rule. The source IP is any, and that means so any IP address, Class A address, B address, C address over any source port. If the destination IP is this address, which is going to be a network, and the destination port is above 1023, then we're going to allow that into the network. And so if we go down to the bottom here, let's look at number 5 here. Now we're mentioning specific destination ports. So if any computer connects to .2 and the destination port is 25, which would be what? Send mail transfer protocol, we're going to allow that. So any computer can connect to .2 on port 25, and any computer can connect to .3 on HTTP. We're going to allow that. Now if you look at this last rule, this looks like it's very restrictive. It's saying any, deny. So essentially what this is saying is if a packet comes in and it doesn't match rule 1, it doesn't match rule 2 or 3 or 4 or 5 or 6 or 7, then it has to match this. Because here it's very liberal. It's saying any source IP, any source port, any destination IP, any destination port. So if it doesn't match any of these, we are going to deny access. And so what this is called is deny by default policy, which is good. And so if any packets don't match any of these first 6 rules, it will automatically match the 7th, which is to deny access. And this is preferable than, let's say, having an allow here, because if we had an allow here, that would mean that we would have to make sure that we covered every possible scenario in here where we wanted to deny or allow packets coming in to our network or leaving. Whereas with this is pretty much a catch-all, saying that, well, geez, if we forget something up here, then at least we're going to deny them here, which is, as I said, it's a lot more stringent. And you're bound to get people complaining because there could be a service that they want to connect to, but they're denied access. But you can always go in once they complain and add another rule up here that covers them. Now, stateful packet filtering, which is more important. If we look back up here, each time there's a packet coming to the network, let's say from this computer here to any computer here, it's going to be inspected for the IP address. However, let's just say that once there's a connection between, and there's no good, let's say once there's a connection between .1 here and .2 down here, if we've allowed this connection before, there's no reason to go and compare the packets involved with that established related connection to all these firewall rules, because we've already done that and we've said, hey, it's okay. Stateless packet filtering is very inefficient because each time a packet comes in that's related to this established connection between point 1 and point 2, it's going to go through and compare the packet headers against each of these rules until one fires. What stateful packet filtering does is it keeps a record of the connections that have been made between a host, between a client and a server, and it maintains something called a state table, which contains a record of all the current connections. And so stateful packet filtering means that once that connection, let's say between .1 here and .2 has been established, that the incoming packet filter is compared with the connections in the state table, and if that table has already been established, it allows that packet on through. There is no reason to go and compare it against these headers right here, these rules here, because we already know that the packets that are involved in that connection are already okay. So stateful packet filtering is a lot more efficient. It speeds up your network, and it's very reliable. This is showing a state table example, and notice that there's 4 separate pieces of information that are required to compare incoming packets with that in the state table, and that is a source IP and port and a destination IP and port. So essentially in this state table, what we've done is that the packet filtering firewall has already established through the rules that this connection is okay. So it's allowed most likely a 3-way handshake, if that's what we're talking about, between if we're talking about connection-oriented connection between .101 and .22 here, that since that's okay, we call it an established connection. So the next packet that comes in is compared against this state table, and if any of the packets match in terms of source IP and port and destination IP and port, then that packet is allowed through, and then there's no sense in going and comparing it to all these firewall rules. And by the way, this is a very simple set of firewall rules. Sometimes you can have thousands of firewall rules. So the more firewall rules you have, the slower your network is going to be, because there are just that many more comparisons that you have to make. Okay, Windows Firewall, one of the most user-friendly packet filters, according to the author. It's an improved version of Internet Connection Firewall, and it can limit the amount of traffic with more precision. That is, you can specify exceptions to rules. And let's see, here they're going to go through this right here. So let's take a look at Windows Firewall. This is an XP machine I'm running right here. We go to Control Panel. saw that pop up. Notice down here, Security Center. And here's Security Center, and here's Windows Firewall down here. Notice I've got it on. I can turn it off if I like, but that's not a good idea unless you've got another firewall that you prefer, and then if you've got another firewall, you can turn this off. Windows Firewall, and here we have our configuration. This is our management console, for lack of a better word, that allows us to turn on our firewall. And notice that this has certain exceptions. Notice it says Windows Firewall is blocking incoming network connections except for the programs and services listed below. So these are important services that Microsoft feels are necessary to properly run Windows, and you may or may not want to include these as part of the default allowed programs. And notice that if you want, you can add a program down here. And so you can select from a list here, or you can browse here. See, on the advanced, it allows us to add exceptions for an individual connected. Select it and then click Settings. So notice I have VMware Network Adapter 1 and 8. Let's go and take a look at the settings. And then we can come in here and determine whether we want to allow connections to the FTP server, IMAP, SMTP, POP3, remote desktop, and so on. Telnet server, web, HTTP. Local area connection, let's go into that. That's going to be our primary connection. I don't have any of these services running, but if I did have an FTP server on my computer, or if I had an HTTP server on this computer, I would have to select this right here. And notice here it says it allows us to specify the external port. Notice this says the default is port 80 right here. And FTP should be over port 21 here. TCP. Okay, and now people could actually access the FTP server and HTTP server running on my computer from outside the network. ICMP, we've already talked about, is used for was originally used for error correction on a network and to send back error messages, which is actually a good idea. In some cases, the administrator needs to know if his network or host or particular port is up or down or whatever. And so this gives you all the different ICMP codes. Notice that there's so many. There's the echo request, timestamp request, mask, router request. Sometimes maybe the only thing you wanted to do was to allow incoming echo requests, and so you would do that, and then anything with the type code of 8 would be allowed through. Okay, let's go back here. And that just shows you some of the other capabilities. So packet filtering depends upon position. The type of filtering a device can do depends on the position of the device in the firewall perimeter and other hardware or software. So you can't just stick the packet filter anywhere. It has to be strategically placed. It has to be thought about in advance in order to properly use its capabilities. So some of the places that you may want to place a packet filtering firewall include between an internet and a host. So this is our untrusted network, and this is our behind our trusted network. Between a proxy server and the internet, the proxy server would probably be in the demilitarized zone or somewhere outside of the network and the internet, and our demilitarized zone, which is something that's outside the trusted network, but still it needs to be connected to by people from the outside, and perhaps people outside of the trusted network or people within the trusted network. So maybe your SMTP server, your HTTP server would be in the DMZ. Okay, this is showing a graphic representation of where to place a packet filtering firewall. Here we have the traditional nomenclature symbol for a packet filtering firewall. So this is in between our trusted network. Here's our proxy server, and here's the firewall. So only certain packets are allowed from the internet through the proxy server back through to the trusted network. And here's one that's at the other end of the DMZ. So notice that we have two packet filters right here. Why would we have two packet filters? Why don't we just have one? Think about that for a second. Here's our trusted network. Here's the untrusted network, the internet. And this is semi-trusted network because of for one reason, and that is that we want to let certain people in through here in order to get at our web server and our proxy server and whatever this is, FTP, Telnet, whatever type of server that is. And so you're going to have less restrictive firewall rules on this packet filter than here, because you want to let people through here to access this and this and this. So what we might do is limit the packets that are coming into here according to, by using rules where the destination IP and port is for this web server or this proxy server or whatever this is. However, we might also want people to access the internet from our trusted network, and so we would have a different set of packet filters here that would be applicable to this sitting behind the internal LAN, the trusted network, and we might even have people creating a virtual private network connection across this to our private LAN. So we want to make sure that we have some stringent rules in here to allow people from, let's say, who are doing work on the outside, let's say maybe contractors or people working from home, to access this internal LAN across the internet. But we don't want to have outsiders being able to get into this internal network. So we're not going to have the same filters, the same firewall rules as here and here. They're going to be different filters. Creating rules and establishing restrictions. So we're going to create a rule base of firewalls, and the rule base tells the firewall what to do when certain kind of traffic attempts to pass. So there's points to consider, and the first is, of course, the most important, is the organization security policy. Is what types of services are we going to be exposing to people on the outside. So if you're exposing, let's say, in this case, a web server and a proxy server, and actually the proxy server is not going to, the proxy server, realize, is going to be for people coming from the outside network through the proxy server and then going out to the internet, whereas people coming in from the internet are going to be accessing the web server, but they probably won't be accessing the proxy server. And so you're going to have an organization security policy. Then you're going to have a firewall policy that's going to be a specific implementation of part of your security policy that indicates what services you're going to expose and who's going to be allowed to access those services and who is not. It's going to be simple and short as possible and understandable, because the more firewall rules you have, the less efficient your firewall will be, because that's just that many more rules that will have to be compared against by the firewall rule by matching to all the packets that are coming in. We want to restrict access to ports and subnets on the internal network from the internet, of course, and that's what I was saying here. However, if you have a virtual private connection that's allowed to be established, and this might be a VPN server, and then you might want people out here to be able to establish and to authenticate to this VPN server and then access this internal network. And of course, you use the firewall rules to control internet services. So in configuring rules, we want to pay attention to logging and auditing. That is, logging if let's say that there's something in particular that we want to be watchful for. Let's say too many packets coming from a particular domain. We might want to log that. We want to be able to track all the packets that are coming in, and we can actually do this right here simply with Linux. We come here, and I'll show you actually this also later on in the Iptables demo. We type Iptables L. This is going to show us all of our firewall rules, and if it doesn't make any sense, if you've already read the and watched the Iptables 1 and 2 videos, then these make sense because I've explained them. But if not, don't worry about it. Just go ahead and look at the Iptables videos. But notice what this is saying here is this is setting up. It's restricting the packets that are coming into the network. And notice here that it's showing you that it's allowing UDP packets from anywhere, any port, to the Internet Printer Protocol here. Notice down here we see this rule called which allows, it accepts packets, and the state is related and established. That's establishing a stateful firewall. And then you notice here there's lots of rules all the way down to here that's actually allowing new connections to an FTP services, SMTP, SSH, NetBIOS, which is useful when a Linux server is part of a Windows-based network, and Telnet and HTTP. So this is very short and simple set of firewall rules. And notice down here we have that reject at the very bottom. We're rejecting it with an ICMP host prohibited. If you recall from our previous example, what this is deny by default, which means if the packet doesn't match any of these, we're going to reject it. And we're not just going to drop it, that is, drop it and not do anything with it. We're going to send an ICMP host prohibited packet back to the source IP address. Now I said if you want to track and audit what you're doing, all the packets that have come in, you can type -L-V verbose number, and this actually tells you, I can't get this any wider to show you what this is, but this tells you the number of packets and the number of bytes that are coming in, all the way down to here. Notice that there are very few for these services down here because I'm actually not running FTP or HTTP, but this shows you 14 packets with 1104 bytes for this rule right here, ICMP type 255. So we can also do network address translation. Recall that's another term for masquerading, which means that you have a single IP address that's serving as the external interface with the computers behind the network. So, for example, here, which is essentially what is used in a proxy server, is that you have a single IP address right here. And back here, you're doling out private IP addresses, so this might be 192.168.0.1.2.3.4.5, and so you have private non-routable addresses for these computers back here, but when they get here, those are translated to an external address so that you can have communications between these individual computers with a private address with computers outside of the network. And so realize that the rule base is the practical implementation of the organization's policy. Essentially, it's the implementation that says, here's our organizational policy and here's how we're going to implement it with firewall rules. So common policies that need to be reflected in the rule base are whether employees have access to internet with restrictions or without restrictions, whether public can access the company's web and email server, only authenticated traffic can access the internal LAN, whether employees are allowed to use instant messaging, traffic from the company's ISP should be allowed or not, whether you should block internet traffic by instant messaging, and only the network administrator should be able to access the internal network directly from the internet. And that's not necessarily the case, but that's probably a good practice unless you're using some sort of VPN authentication in order to access the internal LAN from the internet.